Hello everyone, my name is Zhi Yu and I will be presenting an overview of my final year project on freeform deformation of 3D solid geometric models. My project aims to document and implement the steps required to create an application that can load in 3D models in the OBJ file format and perform the freeform deformation algorithm on the loaded models. The application will be developed in C++ with OpenGL 3.3. The freeform deformation algorithm was originally proposed by Sederberg and Perry in 1986 for editing surfaces and solid models. The main idea is to create a control mesh, usually shaped like a parallelepiped, such as a cube that encompasses the model, with control points located at fixed distances along this control mesh. Every vertex on the 3D model will be mapped using a trivariate Burstian polynomial to each of the control points multiplied by a weight value. After the weight value has been calculated, it will remain fixed until a new model is loaded in. This means that when a control point is moved to a new location, the vertices of the 3D model will be updated to satisfy the trivariate Burstian polynomial equation that was defined earlier. This allows the user to move the control points to update the 3D model without directly touching the model's vertices. The key features of the actual application will include an OBJ model loader, which can load in 3D models in the OBJ file format. Other key features include basic functionalities like window generation, camera movements, drawing of the 3D models, and functions that handle user interaction, such as mouse picking using raycasting to move the control points to different positions. And of course, the application will have functions that implement the freeform deformation algorithm, such as drawing of the control mesh and updating the model when a control point is moved. Before moving on to the demonstration, here are some extensions proposed by other researchers. First is the extended freeform deformation, which proposes the use of control meshes with more complex shapes and also allows the control mesh to be applied to local regions of the model, which will allow small bumps of features to be created on specific parts of the model. Another extension is to add constraints such as the theory of elasticity to create more realistic deformations by simulating a specific material type, such as plastic, on the 3D model. However, these extensions are not implemented. Now we move on to the demonstration of the application. When the application is first started up, a default model will be loaded in. In this case, we have loaded in Blender Suzanne, which is this monkey over here. You can move around using the WASD key and by holding down the left mouse button and looking around. You can deform the model by holding down left click on one of the control points and dragging it to a new position. Under the settings panel, we are also able to show or hide the control grid to get a better view of the model. And we are also able to reset the model to its default state. Now I'll be loading in another model, and this is done by dragging and dropping the OBJ file of the new model into the window of this application and clicking on the load button. Now the bunny model has been successfully loaded in, and we can perform freeform deformation on the bunny as well. This concludes my short demonstration of the application. Thank you.